Короче, кто помнит, у меня был скрининг в Дубайский фудтех на $10 000, и меня все-таки позвали на техничку, которую я сегодня и покажу. Как мне обещали на скрининге, мне дали задачу про марсоход, который перемещается по Марсу, имеет непосредственно координаты и какое-то направление. Но самое важное, нужно использовать лучшие практики DDT в юнит-тестирования и все в таком духе. Потому что компания это очень ценит, это чуть ли не входит в ее философию. Но, честно говоря, я не особо-то и готовился к этой техничке, а особенно к жесткому покрытию тестами всего своего функционала. Да и вообще за все время прохождения техничек на западный рынок, а их было порядка 70-80, я никогда не встречал задачи настолько сильно связанные с тестированием своего кода и с уважением лучших практик TDD. Ну ладно, не буду больше распинаться. Всем приятного просмотра.
Thank you for being on time. So first of all, let me introduce myself. So my name is Johan. I'm an engineering manager here at Talabat, and I'll be conducting the session for today. Basically, what we're going to be doing today is just checking your problem-solving skills, the way you look at various problems. So just a couple of things for today's session. If you are using any AI assist while you implement code on your day-to-day, the ask is just to turn that off for the session, please, because we want to make sure that we can evaluate your skill set. But if you feel you want to ask ChatGPT a quick question or you want to Google some syntax or something like that, feel free to do that, right? We just want to make sure that we don't have AI answer the question for you. And also, please, please, please don't take the question and post it in ChatGPT. If you can give us a quick introduction or give me a quick introduction about yourself, just so I can understand a bit more about you as a candidate, maybe a bit about your background, and then we'll get started.
Yep, sure. I'm a senior Golang developer with 8+ years of experience working at blockchain, fintech, e-commerce, currently as a senior Golang developer where I've been building like core infrastructure for crypto payments, and I worked on the, for example, pricing and routing engine that compares quotes across multiple PSPs and liquidity sources that work increased checkout conversion by 8%. I also led backend development of B2B crypto payments APIs, like focusing on idempotent endpoints and webhook delivery, like pipelines, which reduced partner integration time by roughly 50%.
So a lot of payment experience, a lot of fantastic crypto experience. So maybe if you can tell me a bit more about your crypto payment integration experience.
I worked extensively with crypto payment integrations and on the on-ramp side, and I built the pricing routing engine that, like I mentioned above, that connects to PSPs and liquidity sources, because works with providers like Wire, Transact, and others. The engine compares real-time quotes across the providers, normalizes pricing data and sources transactions to the best liquidity source based on conversions, rate optimization, I guess. And that required handling different API contracts, rake liquidity, limiting, and fallback logic with providers go down or return stale quotes.
So I didn't quite give you a background of what I do at Talabat. So I'm currently leading the billing team as part of the FinTech tribe. The reason I'm asking you about these payment details specifically is because these are open topics within Talabat. So it's very good to hear about that experience. So just moving on to the next part for you, I'll quickly give you an intro of what we're going to be doing today. You'll be working on something that we call a toy problem. So that's basically a problem that you can solve within a very short amount of time. Before we go on to the actual problem, I just want to give you a high-level overview of what we value as an organization. What we value at Talabat is shortening the feedback loop. So getting feedback on everything we do as quickly as possible. Small development, build it, release it, test it, small feedback loop. So the expectation is to follow TDD when implementing it. Another thing that we value at Talabat, or that we strive for, is that quality enables speed. In order to go faster, you need to build your functionality. You need to build a robust ecosystem that is very high quality. And then the last thing is that product engineering, or we follow product engineering over just task execution, right? So especially as a senior software engineer, the expectation is for you to own the end-to-end life cycle of whatever you are developing, right? So it's not just a matter of executing tasks, getting it behind your back and then moving forward, but actively owning the products that we build. What you can do in the meantime is you can open up your IDE, and then I'm just getting the Pastebin link ready for you. And then we will, in a short amount of time, quickly start with that.
I can just copy and paste it in my idea, right?
Perfect. Yes, please do. And if you can also start sharing your screen,
Yeah.
I think we can get
Just a minute.
started. No worries. No worries. Take your time.
Demonstrate.
Yes. So the reason I need to see your IDE is because I need to see how you operate. So I need to see, where your starting point would be when you implement anything, exactly the steps that you follow. So what we can do now is you've got the question in front of you. Just to reiterate, and I know I've already mentioned it before, but this is part of the question, so I'm just covering it. So we value test-driven development, the solution and growing in very small incremental steps while explaining your intentions and design decisions to the interviewer. Don't worry about completing the whole assignment. I want to give you some time to ask any questions, to go through the question itself, so that I can clarify anything that you're not certain about.
Should the grid have boundaries, or it's infinite in all directions,
Don't worry about the boundaries. However, we want to see that you can imagine that they could one day be boundaries, but for the initial implementation, you don't need to stress about the boundaries yet.
What about commands? How should invalid commands be handled? Ignore them, or return an error, or stop execution?
So what we can say for now is you can expect only those 3 commands. But what we also might follow up at the end is, so, okay, if you would receive invalid commands, how would you handle it? So for now, let's make that out of scope. However, once again, very, very valid question. Of course, based on time, if we have more time, we can go through all of them. I think it's very, very valid.
Okay. If so, I would start with the domain first design, maybe.
Yeah.
We just have 2 objects like rover and direction, right? So we need to implement command execution, for example, step by step. Exactly how TDD would evolve. We can create some type, like direction of int. We can create our directions, for example, north. Also, we can create a rover type. It's like a struct that contains our coordinates. So we have an initial coordinates contains the north direction.
That is correct.
So if we're working with the strings, we can work with directions in the same way.
So just as a reminder, the expectation is to apply test-driven development, right? So if you want to maybe try and apply TDD a bit more on this, that might be a bit beneficial, just because you can test and validate your assumptions as you go.
Yeah. In terms of TDD, I'll just isolate the behaviors into small methods. So we have our rover, and now we can just create some movements for it. For example, we can turn left side and I guess this is just we need just to change the direction variable inside it. Like if we have only 4 directions, we can just use the counterclockwise, like add the 3 and get the model of it. In these functions we is working with direction. Now we need to work with movement themselves. We can rely on the rover direction. So if we have, for example, case of north, just increase this coordinate, and south respectively.
How are you going to validate that what you've implemented up to now is or will work as expected?
That's a good question. Like validate using small focused unit tests, for example, for each behavior. And then I would outline concrete tests. For example, initialization state, turn left state, turn right, move, something like that.
How would you implement the test as you're going? So maybe if you can show me how you'd implement those tests.
Yeah, sure.
Yeah.
For example, we can validate the input parameters and just use the fatal f string. For example, something like expected, and the same thing for just turn right. East in this case. So east. So we also can test the move function to for example, we can move to the north. Yeah, like this.
Okay.
Maybe for east, for example. If we're turning to the right.
Okay. It says on line 13, the rover receives a string of multiple commands and turns its position after executing the commands. Could you make it so that the rover can actually take in a command like this? Well, what do you need to do in order to actually implement that and then to test that? Or test that and then implement that, however you would do that using TDD.
Yeah. And I just gonna do that, like to create some process command string function that can take the string of commands and yeah, just iterate of the symbols.
Okay.
From the std in, for example, yeah. And call execute method, just passing the commands.
Okay.
So
Can you run your test for me, maybe? Let's quickly see. Can you run all of them? Have a look now. That should work.
missing return. So we need just to return some, for example, empty string, right?
When we do execute using test-driven development, that we can test on a frequent basis. If you can't set up the test, then that's a problem. Okay, so that seems to be working now. Okay. Constantine, if we can maybe have a look at which tests you've created so far.
Yeah, sure.
Maybe you can talk me through what you're testing up until now.
Right now there are 3 levels of tests, I guess, like progressing from simple and composed behavior. Like test move north, this verifies both movement logic, and turn left, turn right too.
Is there a way we can validate turning the rover to south?
Yeah.
That will work, right? So what I would like to see is, of course, when the rover is facing west, and you move it one move, it should go to x minus 1. And when the rover is facing east and you move it once, it should go to x plus 1. And the same for if it's north, it should go to y plus 1, and it's facing south, y minus 1. So I would like to see a bit of those as well, just to see how the rover would respond for those. How would you set up those tests?
Yeah, sure. Like we can create another one, for example. Turn to south. Move to south, for example.
So just to check now, in terms of your functionality, you are currently testing that you can get the rover to point into all of the various directions. So that is turning right. Is it possible to currently test that your turn left will also bring the rover around? Do you have that one? Could we currently do that?
Yeah, sure. Can also add some rotation cycle, for example, like four left turns should bring back to north.
Okay. There we go. Yes, we only need 2 for that. Okay, cool. Is your rover's implementation, is this production ready?
I think not yet production ready, but very close.
Okay, what do you think we need to do to get it production ready?
Core logic is solid and well structured. I think I have like isolated behaviors and good unit tests coverage. However, for production readiness, I'm currently missing input validation, for example.
Okay.
In this case, for example, handling invalid commands instead of silently ignoring them, and
Okay.
a few questions that I'm not give you in the beginning.
Okay.
And there is no concept of environment yet, so no grid boundaries or obstacles,
Okay.
which would be essential. Error handling is absent. For example, execute doesn't return errors or status, which makes it harder to integrate into a real system, I guess.
Do we know that this rover can move south based on what you've tested so far? We know it will do that, so you can turn it up, but we don't necessarily know if it will move south. But we don't have to go into too much of that now. Let me then go on a follow-up. Now you decide you want more flexibility with the rover, right? You've realized that having 4 directions doesn't quite make sense because maybe you want to be able to move diagonally. You want to be able to add some more directions to it, right? So how would you go about?
That's a good question. I would move away from from a num-based directions, switch to a vector-based model, maybe. The main idea is instead of store 4 static directions, we can use directions like this. For example, so north would be west like this, and if we talk about diagonals,
You can just add one for now. Yeah, you don't have to add all of them. But it's fine. Okay, so just to understand, what you would do is you would say if it's facing this direction, these are the commands that you would want it to apply, or the directions that would need to apply. If we wanted to be able to go around, so we know Mars is round, right? We know that at a certain point in time, you will get back to the other side. You'll go completely around Mars. Okay. So for argument's sake here, let's imagine it's a grid of 10 by 10. Not 10 by 10, but you can go 10 to east, you can go 10 north, 10 south, and 10 west. So technically it's a 20 by 20 grid. If I am currently on the 10th spot of X10, if I go one more spot east, that would mean that I get to minus 10 from the opposite side, but I'd still be facing east. How would you implement this grid so that it would loop around the round planets?
We can use model wrapping on coordinates. I think
Okay.
that's the cleanest, most scalable way. And just treat the grid as a circular, and X range from minus 10 to 10, Y range from minus 10 to 10, and when crossing boundary, wrap to opposite side.
I'm facing east and I'm moving, right? So I was on 10 and now I'm going to go to minus 10. What would that implementation bit look like?
Implementation would be like we can implement it directly at the point of movement, right? After updating the coordinate.
Cool. Oh, that makes sense. Yeah, that makes sense. Do you see any particular code smells or anything that you would want to refactor in the short term?
I would say movement plus boundary logic not encapsulated. No, right now, move function only updates coordinates, and wrapping is separate logic. So, but the better approach is to extract a wrap helper, for example, or normalize the function and call it inside move. Maybe some problems with direction switch duplication.
I'm just checking. I think it's not bad. So if we look from a functional perspective, your turn left is a small function. You don't have any particular big functions. You don't have anything that's doing more than one thing at the moment.
We can pass the arguments into the constructor, for example, if we need to have another initial state of our with
Okay. Okay. Cool. I think that covers pretty much all of my questions.
Ну, как-то так. В целом техничка была несложная. Нужно было просто написать функциональность под марсохода и протестировать ее. По сути, это все, что нужно было сделать. Ну а теперь мне остается ждать только обратной связи. И если ответ будет положительный, то я пойду на System Design. Ну и как всегда, если тебе понравился этот видос, если ты досмотрел до этого момента, то поставь лайк, оставь комментарий. На этом канале я обычно выкладываю собеседования на западный рынок, как на русском, так и на английском, неважно, в какие-то крупные компании на большие офферы. Просто чтобы поделиться своим экспириенсом, своим процессом прохождения интервью. Ну а также не забывай про мой канал в Телеграме. Спасибо тебе за просмотр. Пока-пока.